Hey everybody, Tim Duncan here, and this pre-calculus lesson is on symmetry and coordinate graphs. Let's first take care of this board problem right here. We're going to see this problem come up in 2 lessons from now. I think it's 2 lessons from now, so keep in mind we're going to we'll talk about this. And so we're going to graph these inequalities right here and find out where they intersect and shade the intersection of them all. So here's x is greater than or equal to 0. X equals 0 is this vertical line. Greater than would mean shaded to the right. So, and I'm not going to shade the whole thing yet because I got to shade the 3 other inequalities. Here's y is greater than or equal to 0. This horizontal line is y equals 0. Greater than is above. So now I'm in quadrant 1 right here. Okay, so here I'm going to go up to this plus 2 and use the slope up 1 over 1. So put a point here, up 1 over 1. And then test 0, 0, and that tells me I'm going to shade that side of that line. And then here's y equals, y is less than or equal to negative x plus 8. So it's going to be in this little quadrilateral piece right here. And then all the vertices, they want you to locate all the vertices also. These ones are easy to figure out, you guys. These ones right here. This one might be a little bit harder. It's where this line, y equals negative x plus 8, intersects this line, y equals x plus 2. So just set x plus 8 equal to negative x plus, x plus 2 equal to negative x plus 8, and you get x equals 3. And you can plug 3 into either one of those to get 5. All right, so symmetry and coordinate graphs. Okay, so point symmetry just means that if a point P and P prime are symmetric to point M, then M is the midpoint of the segment P, P prime. Origin symmetry happens if when you plug in negative x into your function, it comes out to the opposite of your function, your negative f of x. Okay, so when you plug in negative x into f of x, it comes out and becomes negative f of x. All right, I have examples of all of these shortly. X-axis symmetry is when you substitute in x comma negative y and you get the same equation. Y-axis symmetry is when you substitute in negative x comma y and you get the same equation. Symmetric with respect to the line y equals x, that's when you substitute in y for x and x for y, okay, into this and into the equation, and if it produces the same equation, then it is symmetric y-axis symmetry, or y equals x symmetry, sorry. Y equals negative x, and I just substitute in negative y for x and negative x for y, and if you get the same equation, then it's symmetric to y equals negative x. Okay, so determine whether each graph is symmetric with respect to the origin. Okay, origin symmetry is when you plug in negative x for in your function, and it comes out to be negative f of x. Okay, so here we go. I'm going to plug in negative x right here. And so when I plug in negative x right here, negative x to the fifth is negative x to the fifth. These two are equivalent. So this is opposite this right here. So yes, it is symmetric respect to the origin. Okay, when I plug in negative x to this one, however, it gets me x plus 2 and this negative x. These are not equal to each other. This is not equal to the original equation right here, so it's or the opposite of it. So no, it's not symmetric with respect to the origin. Okay, here's one that I want you to xy equals 2. Is it symmetric with respect to the x-axis, y-axis, the line y equal x, or the line y equal negative x, or none of these? All right, so the x-axis, we're going to substitute in x comma negative y, and when I plug x comma negative y in, then it becomes negative xy equals negative 2, or xy equals 2, and that's not the same equation as xy equals negative 2, so no. And same goes for y-axis symmetry when I substitute in negative x comma y, and then when I substitute in y comma x, I just reverse the ordered pairs. Well, yx is the same as xy, then that's the same equation right there. So yes, it is symmetric with respect to the line y equals negative x. Substitute in negative y comma negative x, and it comes out to be xy equals negative 2 again. So yes, it is symmetric. And this graph, here's the graph right here. Here's the line y equals x right here. And can you see if I folded it right in half that this guy would fold over on this side right here? Here's the line y equals negative x right here, and if I folded it down this line right here, then this side would fold over on that side right there. Okay, so that it is symmetric to respect y equals x and y equals negative x. Okay, so determine whether the graph of x squared plus y equals 3 is symmetric with respect to the x-axis, y-axis, the line y equal x, the line y equal negative x, or none of these. Okay, so here's x-axis. So I substitute in x comma negative y, and it does not give me the same equation. Y-axis symmetry, I substitute in negative x comma y, And negative x, when I square it, becomes positive x, and x squared plus y equals 3 is the same equation. So it is symmetric with respect to the y-axis. Y equals x, I substitute in y for x, and then so there's y squared now plus x for y, and so no, those aren't the same equation. And same goes for y equals negative x. I substitute those in. Again, it's a big no. So the only one it is y-axis symmetry on that one right there. All right, so these are just the rules on these guys, and you probably already have them written down, but there they are just for your review.